Welcome to our video on Java control structures. In this session, we'll begin with an introduction to the essential control structures in Java that guide the flow of your programs. We'll explore decision-making structures, including if-else and switch statements, and dive into looping structures such as for, while, and do-while loops. We'll also discuss how to control loop execution and handle exceptions within these structures to ensure robust and error-free code. Whether you're new to Java or looking to refine your control flow techniques, this video will provide valuable insights and practical knowledge. Let's get started. In programming, you often need to control the flow of your code based on conditions. The if statement allows you to execute a block of code if a specified condition is true, using the syntax if condition code to execute. If you want to handle both true and false scenarios, you use if-else statement, which executes one block of code if the condition is true and another if it's false, with the syntax if condition code if true else code if false. For more complex scenarios involving multiple conditions, the if-else statement checks each condition in sequence, executing the code block for the first true condition, or the else block if none are true. This is done using the syntax if condition 1 code for condition 1 else if condition 2 code for condition 2 else code if no condition is true. The switch statement is a powerful tool for executing code based on the value of an expression, making it ideal for handling multiple discrete values. Its syntax is switch expression case value 1, code if expression equals value 1 break, case value 2, code if expression equals value 2 break, more cases default, code if no cases match. For cleaner and more type-safe handling of enumerated types, Java 5 introduced enhanced support for enums in switch statements. When using enums, you write switch enum value case enum underscore constant 1, code for enum underscore constant 1 break, case enum underscore constant 2, code for enum underscore constant 2 break, more cases, which improves code readability and reduces errors by ensuring that only valid enum values are used. The for and while loops are fundamental for repeating code blocks in programming. The for loop is ideal when you know how many times you need to iterate, using the syntax for initialization, condition, update code to execute. For example, for int I equals 0, I5, I++ system.out.println I, prints numbers from 0 to 4. Conversely, the while loop is useful when the number of iterations isn't known ahead of time, continuing as long as a condition is true. Its syntax is while condition code to execute, and an equivalent loop to print numbers from 0 to 4 would be int I equals 0, while I5 system.out.println I++. Both loops offer flexibility for different scenarios based on how you need to control the flow of your code. The do-while loop is a variation of the while loop that guarantees the block of code inside it will be executed at least once before checking the condition. The syntax for a do-while loop is do code to execute while condition. The enhanced for loop, also known as the for each loop, simplifies iteration over elements in an array or collection without needing to manage an index. Its syntax is for type element, array or collection code to execute. In loops, control statements such as break and continue are used to manage the flow. The break statement exits the loop immediately, while the continue statement skips the current iteration and proceeds to the next one. For example, you can use break to stop a loop based on a condition, and continue to skip certain iterations and move on to the next one. As we conclude our study of Java control structures, we've navigated through the essential mechanisms that dictate the flow of execution in Java programs. We began with an introduction to control structures, setting the stage for more detailed exploration. Our examination of decision-making structures has shown how to implement conditional logic, enabling programs to respond dynamically to different scenarios. We then delved into looping structures, which are crucial for performing repetitive tasks efficiently. We also explored techniques for controlling loop execution, enhance our ability to manage complex iterations. Finally, our discussion on exception handling has illustrated how to maintain control flow in the face of errors, ensuring robust and reliable programs. As we wrap up, it's evident that mastering these control structures is fundamental for creating effective and resilient Java applications. For OMINI.